Okay, this is the Chapter 3 video tutorial. I chose Chapter 3 Problem 14, and that states a tennis ball is struck and departs from the racket horizontally with a speed of 30 meters per second. The ball hits the court at a horizontal distance of 20.5 meters from the racket. How far above the court is the tennis ball when it leaves the racket? So I drew a picture of the tennis racket and the ball, and we're going to call this right here the height from the ground, and then it gives us this distance right here, 20.5. So the ball is going to fall in a projectile type of way, and then it's going to travel that distance s, which equals 20.5 meters. And then it says that it departs from the racket with a speed of 30 meters per second. So this vector right here, velocity equals 30 meters per second. Okay. And then just for reference, this is x, and then up here would be y. Okay, so I guess it helps to write down what we know. We know first that the displacement will be equal to s. We also know that the acceleration in the y direction is equal to negative g. And then y naught equals h. This is y equals 0 right here. That's where it's going to hit the ground. So y equals 0 when it hits the ground. And then x naught equals 0. And then the velocity in the y direction is 0 because it's not traveling up at all. Okay. And then we could start with an equation that has all of these variables in it: v naught y t plus 1/2 ay t squared. We know that y equals 0, so we can substitute that in. Y naught is equal to h, so we can substitute that. V naught y equals 0, that cancels out this and t, so then we're left with a negative 1/2 because of the negative g times g times t squared. So since this side equals 0, we can just move the h over, and it would be equal to 1/2 times gt squared. The negative cancels out, so technically we added this onto the other side, so both sides are positive. And then for the displacement, we can relate this by saying the initial velocity in the x direction times the time, and then we can solve for time by just dividing both sides by initial velocity, which gives us this. And so since this is equal to t, we can substitute it in here for t. So now we have h equals 1/2 g times s over v naught x squared. And then we could do this. So technically it's this, the 1/2. And then we have gs squared, and then v naught x squared. So now we're looking for h. this. So this is 9.8 meters per second. Okay, and then we have s squared, which is s is 20.5 squared, and then divided by v naught x squared, which is 30 squared. And if we type that into our calculator, we have 20.5 squared, which gives us this is 9 meters per second squared, oopsie. Which gives us, hang on, let me rewrite it over here so I have more room. 9.8 meters per second squared times 42.25, and then 30 squared is 900. So then we'll do 9.8 times 420.25, which equals 18.45 divided by 2 times 900. So 2 times 900 is 1800. And then 4118.45 divided by 1800 equals 2.288, which if we round that to 3 sig figs, 2.29. And then it's a height, so it's in meters. And that's our answer.